Hi folks, today we're looking at the Math 61B Chapter 4 assignment from 2021. The first part has no calculator and it leaves some space to make a unit quarter circle, so I think I'll do that to start with. You can of course skip around in this video to wherever is going to be the most helpful for you, so definitely don't feel like you have to watch the whole thing. If you're okay with making a unit quarter circle, then of course skip this part. So I'm going to write my angles that are important. 0 degrees is 0 radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. And 90 degrees is pi over 2 radians. And that's because 180 degrees is pi radians. All right, here's an easy point to grab. Here's another easy point to grab. And now I head over here and I think about 1, 2, 3. So all of these values are over 2. X values are cosine. Y values are sine. And I've got 1, root 2 over 2, root 3 over 2. Same for my sine. 1, root 2, root 3 in ascending order. If I want to put those tangent values on, tangent's always y over x. So for this first 0 degrees, or 0 radians, I get 0 over 1, which is 0. Up top, I get 1 over 0, which is undefined. And for the other ones, I have 1 over root 3, which you can also write as root 3 over 3. And 1 and root 3. Throughout the assignment, I'll be referring to this unit quarter circle. The first question asks us to sketch each angle in standard position. So I'm going to make some axes and sketch. I'm going to show that I'm going in the negative direction. There's negative 120 degrees. And my reference angle would have to be 60 degrees. Reference angles are always positively framed. And they're always with the x-axis. 9 pi over 4. So that's 9 45-degree angles. So here's 2 45s, 4 45s, 6 45s, 8 45s, and another one. You might want to put this in degree mode sort of in your brain. But there's 9 pi over 4. It's beyond 2 pi. And it has a reference angle of pi over 4, which you can also write as 45 degrees. The next question asks us to find sine, cosine, and tangent for the angle in standard position that is created by this point here, 4, negative 2. Okay. So that means we're talking about this angle. And to do any of this stuff, I have to find the length of this sort of terminal arm, or this bar here, which is always the square root of x squared plus y squared. And that's going to be 4 squared plus negative 2 squared, which will give me root 20. You can reduce this if you want. Optionally, that's the same as 2 root 5. I'm okay either way. And then cos theta, sine theta, and tan theta just have definitions in standard position. Cos theta is x over r, sine theta is y over r, and tan theta is y over x. The main thing is that we get some appropriate values for these. So 4 over root 20, negative 2 over root 20, and negative 2 over 4. Okay, y over x. You can reduce these down. There are a whole bunch of ways that you could write them. I guess the nicest rationalized form of this one would be 2 root 5 over 5. This one's going to be negative 1 root 5 over 5. And this one's going to be negative a half. But correct marks for having any form of it, in my books anyways. All right, the next one, the sine of 45. This is not just asking you to find 45 and write it as a radian measure. It's asking what's the sine of 45. In other words, what's the y value on the unit circle? So they've told you, or they've told us rather, the angle. So let's draw it. 45 degrees is going to look like this. Okay. And I can know that my reference angle is going to be 45 degrees. It is just 45 degrees. So I can head up here and I can see, the y value at 45 degrees is root 2 over 2. So the sine of 45 degrees is root 2 over 2. Here, we're talking about the x value on the unit circle. Now, these things do have meaning in terms of a ratio. Like cosine is talking about how far you go over compared to the length of the radius, or the length of the hypotenuse. X value, not on, of, but rather on unit circle. Okay, so again, they've told us the angle, so let's draw it. Negative 30 degrees. I do find the iPad a little slick here, so it's not that easy to draw on. But theta r is going to be 30 degrees. So my drawing's not amazing, but it's okay. The cosine of 30 degrees, we can see right here, is root 3 over 2. And then I just have to decide, like, in this quadrant, is cosine positive or negative? It's in quadrant 4. It must be a positive value. Same within the last one. They're all positive in the first quadrant. Last one was pretty easy. Since we were just talking about stuff in the first quadrant, the unit quarter circle fully covers us. Next one, the cosecant of 4 pi over 3. This angle here is never going to change, so don't flip it upside down. What this means is 1 over the sine of 4 pi over 3, okay? Or the reciprocal of the sine of 4 pi over 3. Now, I can go off and figure out the sine of 4 pi over 3. But again, notice I didn't do anything to the angle. If I draw 4 pi over 3, it's like 240 degrees, looks like this. It's going to have a reference angle of pi over 3. Okay. So that lets me go to my unit quarter circle and say, what's the y value at pi over 3? Hey-o, it's root 3 over 2. So the sine of 4 pi over 3 is root 3 over 2. It's in a quadrant where sine is negative, so it's going to be negative root 3 over 2. And once I do all that stuff, this over here is just saying flip it upside down. Okay, so I'm just going to quickly undo the sketches I just made. But it's asking us to take this number right here and flip it upside down. So you can write it as negative 2 over root 3. If you want to rationalize that, you can, negative 2 root 3 over 3. But it's not required, at least not in my books. So find the sine of 4 pi over 3 and flip it upside down. Tan of 3 pi over 4. Again, we know the angle, so let's draw it. There's no question what the angle is. It would give us a reference angle of pi over 4. And what's the tangent of pi over 4? I can see it in red here. It's the number 1. So I know that the value is going to be 1, and in this quadrant, tangent is negative, because tangent is positive in quadrants 1 and 3. Lastly, secant means 1 over the cosine. And again, we don't flip the angle. We just flip the whole ratio. So that comes from the idea that secant theta has this definition. It's 1 over cos theta. The angle's not changing here. So now I can go and figure out what the cosine of 3 pi over 2 is. I'll go off into my sort of dreamland here and talk about the cosine of 3 pi over 2. It happens to be right here. It's on the axes. It's at the point 0, negative 1. And cosine's always the x value. So cosine is 0. If cosine is 0, then its reciprocal is 1 over 0, or undefined. And we should say undefined. We don't want to leave a final answer of 1 over 0. Briefly explain why the angles pi over 3 and negative pi over 3 are not coterminal. There's a lot of great explanations here, but make sure that they actually refer clearly to the situation. So a great explanation would be they're not even in the same quadrant. Not even in the same quadrant. And I show a picture to show that that's the case. Some people say they're not 360 degrees apart from each other. That's another good way to decide this. That's just an example. All right, so now we're going to solve secant theta is 2 over root 3. So that means 1 over cos theta is 2 over root 3. And I'm going to flip the whole equation upside down on both sides. And I get cos theta is root 3 over 2. And again, I can go to my unit circle, and I'll figure out there that the reference angle is 30 degrees. After I've done that, cosine, I'm thinking about this, cosine's positive root 3 over 2. So I could be in this quadrant or this quadrant. That is where cosine is positive. So my final answer could be positive 30 degrees, or this one here, which would be 360 minus 30 degrees, or 330 degrees. Find the general solution to tan theta equals negative root 3. Use radian measure. So I got to find my reference angle. Let's head up here. Where's tan root 3? It's happening right here at 60 degrees, or since we're in radian measure, pi over 3. Okay, now I'm going to choose some quadrants. Tangent's negative in the second quadrant and in the fourth quadrant. Now there are many ways that you can show what the angles are going to be because you don't have a restricted domain, but I think it makes the most sense to find this one and call it 2 pi over 3, and to find, say, this one and call it 2 pi minus pi over 3, which would be 5 pi over 3. Those are two solutions within the first revolution. Now that we have our two solutions written, we've got solutions in the first revolution. Let's turn it into general solutions. So give them each a plus 2 pi n to say that they recur every revolution. If you really want to get fancy, because it's tangent and those answers are just 180 degrees apart, you could write it like this, but you are not required to. Okay, it's still correct by writing it as we have it up here, like this. All right, hence give the solutions to the exact same equation, but on a specific domain. So if I think about the pictures of the solutions that I just gave, there's pi over 3, there's pi over 3. Okay. What are we going to call these? Well, I'm allowed to go up to 1.5 revolutions in the positive direction. I'm going to run into an answer of 2 pi over 3. I'm going to run into an answer of 5 pi over 3. And I'm also going to run into an answer of, see if this works in yellow here, of this one, which would just be 2 pi plus 2 pi over 3. So that's 8 pi over 3. Okay. It's a coterminal buddy of the red one. So really it was just adding 2 pi onto this. And then finally, we have one in the negative direction as well. So we've got this one right here. That's negative pi over 3. We don't put any plus 2 pi n's here because it's looking for specific solutions on that domain. Consider the angle and standard position of 10 radians. In what quadrant does it terminate? So we've got these 4 quadrants, and we're just wondering where does it go. So a couple of options here. Each radian is about 57.3 degrees. So this means approximately 573 degrees. If I went around, this would be 180, 360, 540. A little further. It's going to be quadrant 3. Quadrant 3. 3. And we can label them this way with Roman numerals. Now, the other thing that you could do is think, how does 10 compare to pi? Well, pi is 3 and a bit. 2 pi is 6 and a bit. 3 pi is 9 and a bit more. Like it's about 9.42. And 10 is just a little more than that. So what does 3 pi look like? This would be 1 pi, 2 pi, 3 pi, and a little bit more. So 10 is a little bit more, than 3 pi, because pi is 3.14. All right, convert 225 to radian measure. 225 is just 5 45s. These are common angles, so that's 5 pi over 4s or 5 pi over 4. If you use a conversion factor, this is going to be a lot more miserable. You'd have to go 225 times pi over 180, which is going to be 225 pi over 180. Those are both divisible by 5, so what will you get? You get 45 pi over 36. Oh my gosh, those are both divisible by 9, and that's going to give you your 5 pi over 4. For something like this, since you can get it done so easily, there'd be the expectation that it's reduced. 11 pi over 6 in radians to degrees, so that's 11 pi over 6s, or 11 30s. Every pi over 6 is 30 degrees. It's on our quarter circle, so we get 330. Moving on to the calculator part. We want to convert to degree measure, so 2 pi over 15, we just times it by 180 over pi. And if you run that through in your calculator, you're going to get 24 degrees. The answer should be in degrees because we're putting it in degree measure. 97 to radian, so we're going to times it by pi over 180. Okay. Exactly, it's 97 pi over 180, or it's about 1.69. Don't write it as sort of part exact value and part decimal, like it's 0.5 something pi. It's either going to be as a decimal to 3 sig fig, or it's going to be exact. Write one positive and one negative angle to coterminal with 2 pi over 3. So if you want to find one in the negative direction, we can just subtract 2 pi from this. And I'd think of that 2 pi as 6 pi over 3. So what's that going to give us? Well, it's going to give us negative 4 pi over 3. Over here, if I add 2 pi to it, because that's just adding a revolution, again, I'll think of that as adding 6 pi over 3, just to get a common denominator, and I get 8 pi over 3. Are these the only possible answers? No, but they're easy ones. They're low-lying fruit. It does say exact values. That means just not decimal approximations. One of the easiest ways to make sure you've got exact values is not to pick up your calculator. Your brain and your pencil working will likely work in exact values. Number 4, the point -6, -7. Maybe I'll go back to blue. I think that shows up a little better. Struggling. Here we go. -6, -7, like somewhere down here, is on the terminal arm of some angle in standard position. We just want to find what that angle is. I think the easiest thing to do here is to say that the tangent is just y over x, or 7/6, and then we can find the reference angle easily. The inverse tan of 7/6. If we do this in our calculator, and we have our calculator in degree mode, we'll get 49.4 degrees. Okay? But that just tells you this reference angle is 49.4 degrees. The angle itself in standard position has to be 180 plus that 49.4 degrees, because we're measuring right here from the positive x-axis, so 180 and another 49.4. Giving us a final answer of 229.4 degrees. Determine whether they're on the unit circle, these points. So the equation of the unit circle is x squared plus y squared equals 1. And I'm just going to throw in these points and see if they work. I saw a lot of people go to decimal approximations. We have to be really finicky here because we want to find out if it's exactly 1 when we put this all in. So that'll give me 64 over 289. This will give me 81 over 289. Wonder, is that 1? I think at this point I can pretty clearly see it's not. And then I get 145 out of 289. No, that's not 1. Only 289 over 289 is 1. So this is a no. The next one, I'll try the same thing. I'll put in the x value of -8/17 in brackets, because I'm going to square it and it'll become positive. And I wonder, will that give me 1? So this will be 64 over 289. I could use my calculator, but I don't really need it here. 225 over 289. Maybe I'd use my calculator to figure out what 17 squared is. And let's add those together. Is it going to equal 1? I get 289 over 289. Yes, that's equal to 1. That's great. So it works in the equation of a unit circle. Therefore, it must be on the unit circle. Is it one of the specific points that we showed right over here? No, but there are infinitely many points on the unit circle. We've just shown a few of the common ones in this little drawing, but there are other ones as well. Moving on, we've got sine of 47 degrees, tan of negative 3 pi over 5, and secant of 60. So the first two we should just be able to plug in. Notice this one's in degrees, this one's in radians, and this one's in radians. How do we know they're in radians? There's no degree sign. It's only in degrees if you have a degree sign. The only sneaky one, I think, is this one over here. Secant of 60 means 1 over the cosine of 60. Because again, the definition of secant is 1 over the cos of theta. Nothing happens to the angle. This is an angle of 60 radians. So I'm going to head over to the calculator and just plug these values in and see what happens. For my first question, I need to make sure I'm in degree mode. And now I'm just going to type in the sine of 47. Find out that it's 0.731. The next one was a tangent question, but it was in radian mode. So let me put that in. And I'll quit. And I'll just type in tan of negative 5 pi divided by 3. Sorry, that's not right. Negative 3 pi divided by 5. There we go. And I get 3.08. The last one was 1 over cos 60, so 1 over cos 60. And again, I just copy down the answer, negative 1.05. And there they are. The last two questions are their equations, so we're wondering what angles give us a cosine of negative 0.6. That's not a value that we're going to find on our quarter circle that we've drawn anyways. So I need to use inverse cos to figure this out. My calculator should be in radian mode, and I want to go inverse cos of the positive of 0.6. And it's going to tell me 0.927. If you go inverse cos of negative 0.6, it's going to give you an angle that is bigger than 90 degrees, which is annoying for a reference angle. You'd like a reference angle to be acute and positive. All right, after that, we're going to decide on our quadrants. That's when the negative comes into play. Cosine's negative in this quadrant and in this quadrant. Here we go. So we have 0.927 and 0.927. And so that gives us an angle of pi minus 0.927, which works out to 2.21. And this one here, which would be pi plus 0.927. And that's going to be 4.07. Lastly, we've got one that we need to solve. It should be really for all theta, not for all x, but it's the general solution. That's what we want. It's also annoying, though, because it needs to be rearranged. So first off, let's move this 1 over. So we'd get 2 cosecant theta equals negative 8. We can divide by 2, so we'll get cosecant theta is negative 8 over 2. And then I can just rewrite this. So that's 1 over sine theta. Cosecant's 1 over sine. They each get a co-buddy. And negative 8 over 2 is just negative 4 over 1. And now let's flip it upside down. So sine theta is negative 1/4. That's a helpful version of the equation, and from here we can operate. We can find the reference angle by using inverse sine of 1/4. If we do that in radians, we're going to get 0.253. And I'll do it in degrees in just a second off to the side, but I'll follow it through in radians. So I'm going to sketch my answer. Could be in this quadrant or this quadrant. 0.253, 0.253. Okay. One of those is pi plus 0.253, so that would be 3.39. And one of them is 2 pi minus 0.253, so that would be 6.03. We turn them into general solutions by putting the plus 2 pi n on them, and then we're done. If you wanted to do it in degrees, it's really the same steps. So we go theta r is the inverse sine of a quarter, and you could pause and grab your calculator, make sure this is going to work out for you. That'll give you 14.5 degrees. And we'll sketch it. And then we'll just write those answers. 180 plus 14.5 is 194.5 degrees. If I'm going to do it in degrees, I'd better write degrees on my answer. And the other one would be 345.5. We're looking for at least 3 sig figs of accuracy. And then plus 360 n. Okay, and 360 degrees n, we should be saying. So in a way, it's easier to do it in radians because there's less to write and the numbers are smaller. Not much easier, though. I hope that you found this helpful. If you have any further questions, come and chat with me, and I'm happy to take a look at them with you. Good luck with the material, folks. Take care.